Okay, let's start to look at the IRO ergonomic checkpoint. Okay, volume is too low. Really? Okay. Let's see. Let's stop. Okay. I'm just gonna give you a brief walkthrough of this checkpoint. Okay, and since this is called ergonomics checklist or checkpoint, and we have to understand its relationship with ergonomics. Okay. Okay. For example, this first part is about material storage and handling, and these are very common industrial engineering, industrial management problems. Okay, and in this first checklist, okay, it says clear and mark transport routes. That's very common sense in IE, in our field, industrial engineering. Okay, but it tells us why. It has some ergonomics implication, ergonomics meaning. It's not just for productivity, not just for efficiency, not just for optimization of the transportation problems. It has meanings in ergonomics. Okay? Clear transport routes with easy access to work sites and storage areas can help to achieve a better workflow. That's IE, right? That's for productivity. Okay, but in ergonomics, that's what we are concerned about, as well as ensuring safe and rapid transport. Safe. Okay. If transport areas are not clearly marked, materials, work items, and wastes tend to pile up on transport routes. These irregular piles not only obstruct transport and production, but can also cause accidents. So that's the real reason why this is listed here, because they may cause accidents. Okay, so on the one hand, while you are trying to boost your productivity, optimize your transport, you also need to be careful about not to cause accidents. Okay, and then it lists the risk and the symptoms. Okay. Okay, so one of the risks is poor work site access. So it's not convenient for the operator. Okay. If these routes are not clear, if something is, okay, obstructing along the path, the operators will find a way to go through. And that creates uncertainty. You don't know what's going to happen. Okay? It's very obvious. For example, if we block something, or if there are some objects on the entrance, on the floor of the entrance, it's not clear. The operators may have to find another way to get through. Okay, and that increase the risk, increase the uncertainty. Okay. So, second risk is, it may cause trips. or stumbles. Okay? And leg, foot injury may happen. Okay? And in certain situations, if you need to evacuate very quickly because of fire, because of other reasons, okay, it will delay evacuation. So that's the risk. Okay? So it tells you these reasons, okay? And how to do it, it shows you how to do it. So these are the solutions, okay, and some of the hints, okay? And it gives you some examples in illustrations, okay? And today, the major manufacturing sites, they are following this very, very well. Okay, they mark where the vehicles should go. Okay, and they also mark where the operators should walk. Okay, they have very clear walkways. Okay. Let's go to, this is pretty much very, so you can read through all these illustrations and the checkpoints by yourself very easily. Okay. This one. Okay, another example, checkpoint 5. Improve the layout of work area so that the need to move materials is minimized. Okay, let's look at why. Machines and workstations are often installed one after another as production expands, and their existing positions are not necessarily suitable for easy and efficient movement of materials. This can be improved by changing their layout. Okay. Time needed to perform a task can be greatly reduced by reducing the movement of materials. This reduces workers' fatigue, allowing more efficient working. This is also beneficial for preventing accidents caused by moving materials. Okay? And what about the risks and symptoms related to ergonomics? Okay? The first one is physical energy demand. Okay? If the layout is poor, okay, the physical energy demand may be increased. That make the operator tired more quickly. Okay? And there may be repetitive strain. Repetitive strain comes from repetitive work. Okay? And excessive fatigue, low back pain, increased injury rates, stress-induced disorder. So looks like if you have a poor layout, okay, eventually these risks may happen. Okay, it is not very clear how to quantify the relationship between a poor layout with all these in ergonomics. However, it is very easy to quantify whether the layout optimize efficiency, optimize productivity, whether the layout increase quality performance, right? So in terms of industrial management or industrial engineering, it is usually very easy to quantify, to show whether your layout is good or bad by looking at the final output, which are quality performance, quality indicators, number of outputs per unit time, that's productivity or efficiency, right? However, here, in terms of all these risks, it's quite difficult to look at, to show that this layout may cause repetitive strain. This layout may cause low back pain. This layout may cause injury rate. This layout may cause stress-induced disorders. So that's the problem. On the one hand, you can show we improve the layout so that productivity increased by 20%, quality increased by 30%, cost reduced by 50%. So as industrial engineers, you are in a very good position to show all these performance, to justify yourself, to justify the value of being an industrial engineer. On the other hand, even if you try to collect these risks, it's still very difficult to justify that the layout is the main reason for increased low back pain. Why? Because these things are very, it's risk. In order to see some symptoms, it takes time. It's not immediate. Maybe for an operator to have low back pain, you have to wait for 10 years. After this operator has been exposed in this work for more than 10 years. And that's what actually happened. Many people, they don't have any problem when they are young. When they are 20-something, they work in a manufacturing site. They don't feel too bad. In their 30s, they begin to develop problems. But they still don't know that's work-related. That's because of the job they're doing. Many people, they use mouse, they use the keyboard every day, every time, every moment. Okay, sometimes you buy a mouse, you buy a keyboard, and it's okay. You can use it. You buy a good sofa, you buy a good chair, you buy a good, maybe expensive bed, mattress, okay? The adjustment of the height of this doesn't work, okay? So, how long does it take for you to develop some problems, some disorders, if you buy a wrong mattress? It's not going to be immediate. It's not like, you buy it today and then tomorrow you get a back problem. you get a neck problem. You have to use that product, the mattress. You sleep on it. After maybe 3-5 years, you develop something. And even if you go to see a doctor, the doctor still cannot tell you. Maybe that's the mattress problem. That is so difficult to establish a relationship between these risks and symptoms. Okay? So we have to bear this in mind. Okay? Ergonomics is one of the, bad ergonomics. Bad ergonomics is one of the hazard today in the workplace. It's just similar to all the other kind of hazards. Air pollution, radiation, what others are there? Noise. See, to develop into problems in your ear, in your hearing, it takes a long time. If you are not protected against noise, probably the first 5 to 10 years you are okay. You're subject to a loud noise. In construction, in the manufacturing, this is very common. If you don't wear your earplug, and you are always hearing bang, 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 for a couple of years, you don't have problems. It's cumulative. It's chronic. It takes a long time to develop into problems. Okay? And that's what we are doing today about ergonomics. Musculoskeletal problems, okay, today, they are being confirmed already. So it's one of the risks. So we have to use this kind of checklist, okay, to protect the workers. That's why we have this kind of checklist. Okay, and it tells you the reason, okay, and it shows you some of the example. So the best way to protect the workers is through, again, industrial engineering. Okay, try to have a good layout. Okay. So if you can improve this workplace by using conveyor like this, it will help a lot. So this operator, this operator doesn't have to rotate the trunk like this one. Okay, this lady, right, in order to get some of the materials, some of the parts, she has to turn. Okay, and if the chair is not turnable, then she has to turn the trunk, turn the waist by herself using her trunk. Okay, if the chair is turnable, then it's probably okay. But if not, and think about this, how many times per day she has to turn? Hundreds, thousands. So that's the risk. And then you are talking about day by day, week by week, month by month, years by year. So eventually 5 years, 10 years, 20 years, she may develop into problems in her low back because rotation, trunk rotation has been identified as one of the main risks. So if you improve it like this one, that would be nice, right? And the flow of the parts goes like that. And she doesn't have to rotate. Okay? Or like this. Okay? So in this book, it gives you a lot of examples like this that you can, okay, even generate some of the ideas. Okay? So a lot of things are just common sense to industrial engineers. For example, this checkpoint 6. Okay? Use carts, hand trucks, and other wheel devices or rollers when moving materials. This is very basic industrial engineering, right? And it tells you why. And it tells you the risks, the symptoms. Again, as you can see, these are the main, that's what they call the main ergonomics hazard. Ergonomics hazard. Muscular strain, excessive force, low back pain, okay, upper limb disorder. Okay, and so these will occur repetitively in this book. Okay, and it shows you some of the tools that you can use here. Okay, that's about the materials. Let's look at other examples. Okay, the second part is hand tools. Let me take a look. Okay, there's one part which is machine safety. Okay, machine safety. Okay, and workstation design. Okay, let's look at this one. Checkpoint 51. Adjust the working height for each worker at elbow level and slightly below it. Why? The first question is why at elbow height? elbow level. The second question is why slightly below it. This checkpoint obviously tells you the optimal work surface height is at the elbow level, slightly below. Let's look at whether that tells you why. The correct height of places where work is done with hands facilitates efficient work and reduces fatigue. Okay? Most work operations are best performed around elbow level. That's what it says. Most work operations are best performed around elbow level. Is that true? Can we find a proof? Okay, let's read further. If the work surface is too high, the neck and shoulders become stiff and painful as arms must be held high. This happens in both standing and sitting. Okay, so that's what it says. If you're working and you have to, obviously this guy cannot do it. It's already stiff. I cannot move the shoulder. Okay, but I can. If I have to work on the surface very high, my shoulder will be like this. Probably even more. That's what it says. If the work surface is too high, the neck and shoulders become stiff. Think about this. This is not going to hurt you if you do this for just 3 minutes, or 1 time, 2 times, a couple of times. But you are working at surface height, day by day, week by week, month by month, years, without knowing that you are working at this kind of posture. You have to raise it. Actually, a lot of you are already raising your, because this is too high for you, or because you are sitting at a low chair. For smaller persons, this may be not good for you. So if you are using your notebook, making a note, or writing, that's what happened. But is this proved already, tested already that this is bad? If the surface is too high, we know that you are using these muscles because you have to raise it. All right? And then you are using your mouse, you are using your keyboard, like that. Or you are assembling something, putting something together. Like this. 8 hours per day. And then, yeah, we can take the video of what happened of the posture. We observe it. It's true. You're raising it. But the problem is, why is this at risk? And what other problems is going to happen months after months, years after years? Do we see any problems? So the first approach, you have to make sure there are problems. So you go to the hospital, you check the data, and then you go to ask the doctors, do you have patients? They come here and then they tell you they feel bad in their neck, they feel bad in their shoulders. What are the problems? Yes, there are a lot. And then you check the background of these people, these patients. And then indeed you find, oh, these are the people who work like this for a long time. So that's one approach. That's big data. So I said, you know, in ergonomics, we are already using big data for 20 years. That's the way we try to establish the relationship, the causal relationship. By looking at the hospital data, the first step, are there any problems? Yes, or neck shoulder problems. Are these people working like this? And yes. So we have to show the proof. How many percent? What kind of height? These are data, big data. And then we have to prove it. We have to compare people working like this with people working like this. Big data. And then we have to prove it. People working like this, they got neck and shoulder problems. The probability is higher than people working like this. Not only this, just by big data is not the only way. When you look at the data shows you something, that's all. The data only generates hypothesis. The data only generates hypothesis. It's not confirmed yet. Only experiments can confirm. So the next thing is, we will ask people. These people are subjects. Subjects just means participants in the laboratory work. We ask some of them, some people, some subjects come into the lab, and then we ask them to type like that. Hours by hours. And then we check their postures. And then we ask them, how do you feel? First day, second day, third day. And then they tell you bad, getting worse. But that's not good enough. These are subjective. How can we believe it? So we develop some measurements. We try to measure whether the muscles here are it says neck and shoulder become stiff. How do you measure stiffness? You want to measure whether it's stiff here. How do you measure it? Here's a very good idea. If you can generate something, you can make money out of this. You can just create some kind of pad, neck pad, and you ask someone to wear it while they are doing their work, and then it will measure stiff. And after 5 hours of work, and you give the alarm. your neck is stiff now. Stop working. Do we have that kind of product now, today? No? We can check. If not, I'm going to patent, make it into a patent. Whoa, amazingly, there are so many neck and shoulder pain or stiffness relief pad like this. People are willing to pay for this because they feel it. So they wear it. Some of it's heated. Right? Look at this girl. She feels so good. Look at this. She feels good. So if you design something, you put it on the surface of the pad, and then it measures the stiffness. And then it will automatically heat up, becomes warm. As you become more stiff, the temperature can increase. Because the temperature, maybe in theory, the heat will make the stiff muscle soft again. So maybe in rehabilitation, they have something. That's why these products are coming out, right? Okay, so if the surface is too high, that's a problem. How about if the surface is too low? Is there a problem? If the work surface is too low, low back pain easily develops as the work has to be done with the body bent forward. This is a serious situation in standing position. In a sitting position, too low a working height causes both shoulder and back discomfort in the long run. Yes, there are also problems. If it is too low, you tend to lean forward like that. And the low back becomes at risk. Okay? Again, you are looking at quite similar risk symptoms. In ergonomics, these are the main ones. Muscular strain, excessive reach, excessive fatigue, low back pain, upper limb disorder, wrong operation. Okay? Okay. In ergonomics, there are usually 4 different methodologies. One of the big data approach is called epidemiological approach. In epidemiological approach, we go to the hospital, we check the patient's data. Basically, it's data analysis using statistics or other different methods, trying to compare the ones at risk versus those without risk, and then maybe we can find something. That's called epidemiological approach. In epidemiological approach, usually use some statement like this. You are seeing them every day. The ones who smoking people have 2.6 times higher risk to get the lung disease or lung cancer than those who do not smoke. Right? You see this every day on the news report. The ones who drink coffee compare with the ones who do not. And then blah, blah, blah. The same thing in ergonomics. The ones who work in a work surface in an improper work surface height may have higher 2 times, 3 times higher risk to get a low back pain than those working at the proper height. You see what I mean? That's called epidemiological approach. You get the data and you analyze the data, you compare them, trying to get some result. But remember, this approach cannot ever confirm anything. This kind of approach only tells you association, not causal relationship. Only tells you association, not causal relationship. Because you are retrieving the data from what already happened. You are studying the correlation between 2 targets that you are comparing. So this kind of approach only gives you at best, only generates hypothesis. Only generate hypothesis. If you are working in the big data area, you need to be very careful. Although you can publish a lot of papers, but all the papers may be garbage. And also a lot of papers actually misunderstand what they can do. They call this evidence-based data analysis. No, it's not evidence-based. It's only part of the evidence. You are only getting association, not causal relationship. To actually trying to get close to causal relationship establishment, you are trying to prove something. Actually, you can never prove anything, but you are getting close to it. You can get close to it by doing experiments. By doing experiments. Okay, that's the methodological idea. I don't have too much time to go over this. In ergonomics, that's what we are very careful about. You cannot just go here and you go to the factory and then you see so many people ill, got low back pain, and then you look at the data and then you jump into the conclusion that these people are by their jobs. No. It's data-based, but it's still not evidence. What we have to do is we bring people into the laboratory and we ask them to do the job, task that you consider bad, you suspect, you have a doubt, because that's your hypothesis. So you generate hypothesis first. These jobs may cause these problems, and then you ask the subject to come to the laboratory to carry out, to perform those jobs, and then you observe. You watch until they indeed develop into those problems. And then you are getting close to establishing causal relationship. You are not there yet. This is still based on a very important assumption that these people, these subjects, have not been exposed to other factors. They are only being influenced by this task. However, they go home, right? So there's a joke. We see some low back pain people, and then he goes to see the doctor. And then he sued the company because this job caused my low back pain. And he asked for compensation, for money. I lose my job. I cannot perform this job anymore. My life was ruined because of this job. And then he checked the data. He checked the literature. Yeah, see, Professor Joe published one paper, many papers. He said low back pain, highly associated. And maybe the reason caused the low back pain. And he hired a lot of lawyers. However, the truth is, his low back pain is not caused by the job he performed. It's actually caused by because they have a baby, newborn baby, and this guy go every day, every night. He goes home and then he holds the baby for too long. And even the baby is already 6 months old, 1 year old. He still likes to hold his baby. And it's heavy. And that's also contributing factors, because he's holding something heavy all the time. Right? So there's no guarantee that your subject, your experiments, okay, can control everything. So we still have to be very careful, even if you carry out experimental work. You are getting somewhere, but still not yet. So it is these two type of evidence based on data, big data, and then plus experimental work, then you can establish some theory. So why ergonomics is being considered as a valid science? That is really because we've done so many things to show that yes, poor job can cause problems. Okay? So there are three other approaches, also very important. Biomechanical approach. We analyze how much force, how big the force, while you are doing this job. So that's another type of evidence. Physiological approach. We analyze how much energy, that's causing you feel tired, fatigue. That's another type of evidence. And then psychophysical approach. We ask the subject their subjective feelings. If all these four show the same thing, in hospital you can see these people are getting ill, getting problems. In biomechanics, you prove, the force very big, very high because of this job. In physiological approach, you show that you're making this person very tired. After every day, after 1 day's work, he's becoming very tired. A lot of energy expended. Psychophysically, you ask the subject indeed feel very bad. All these four together, then you are establishing that is risk. When we say risk, we don't say, we are only saying risk very conservatively. See that? We are not saying causal relationship. We are still saying it's risk. So, this is the checkpoint. We are establishing that the working height is a very important risk factor in ergonomics. We are still not saying that poor working height will definitely 100% cause your low back pain. No. We are just saying it's one of the risk factors. Okay? Okay, let's take a 10 minutes break.